Hey y'all, in this lesson, you're going to learn about conditional probability. So this is the probability where you're going to be seeing like find the probability of B given A or A given B or whatever. So you're going to see that word given, and that's going to be conditional. Whenever we're talking about conditional probability or that word given, in symbols, it's going to look like this. So it's going to have that, it's going to have a capital letter here for one event. And then this long bar means given, and then A represents the other event. And I am going to walk you through the formula first, and then I'm going to show you a simpler way to do it. So this is the formula. And so in order to do the formula, you have to know what an intersection is. So we're finding the intersection of the two events, and then we're dividing it by the second event that appears. So these letters may not be in that order. So you're going to have to substitute in whatever, events need to go there. But the second event listed here goes in the denominator here. And then in the top is the intersection. So I have an example, and we're going to practice using the formula from a sample space R, 1, 2, 3, 4, 5, 6, 7, 8, 9. A is represented by a number chosen being odd. I'm going to go ahead and list out what that is. So 1, 3, 5, 7, 9. And B is represented by the number chosen being a multiple of 3. 3, 6, 9. That got ugly. So if we find just the probability of A, this is the set of A, or the event A, and this is my universal set. So that's going to be basically my sample space, my possible outcomes, my possibilities. So A represents 1, 2, 3, 4, 5 elements out of 9. So there's a probability of the number chosen being odd is a 5/9 chance, 5/9 probability. And then it says find the probability of A intersect B. Well, the intersection of A and B are at 3 and 9. So this intersection is just 3 and 9. Therefore, the probability of getting, that is a 2/9 chance. So now we have the two pieces of this formula. We have the intersection of the two events, or the two sets, and then we have the probability of the second one in here, second one in there. So if we find the probability of B given A, which is the probability that the number is a multiple of 3, given that the number is odd, using the formula, we can substitute in our pieces, and we get 2/9 over 5/9. Then we're going to simplify that by flipping the second number and multiplying, and we get 2/5. So the probability of the number chosen being a multiple of 3, given that the number is odd, is a 2/5 chance, 2/5 probability. Another way to look at this is, instead of worrying about a formula, maybe understanding kind of where that formula is coming from. If we look at the second letter in this probability of B given A as the sample space, if we make it now our universal set, it's not really, but if we just think of it in the scope of this problem, then that second letter listed, the given, that is going to be our universal set, our new sample space. And then we're saying the number is odd given that, the number is a multiple of 3, given that the number is odd. But if we use the formula to kind of translate this into a more logical mindset, that denominator is now our total number of outcomes, is our new sample space. And we know that there are 5 numbers in that sample space, 1, 3, 5, 7, 9. And then if we're looking for multiples of 3, given that they're odd, so this is our new sample space, how many of those numbers are multiples of 3? 2 of them. So we're just kind of changing the universal set. And when we change the universal set to the second letter, the given that, then that changes our denominator. That changes our new total. And then we're only looking at that sample space or that set to figure out the numerator. So either way is fine. They're both going to get you to the same answer. So whichever way you feel like it makes more sense, then you go for that. So this was, I went ahead of myself a little bit to this. Next page. Given a family with 2 children, find the probability of each event. So we're going to build a sample space for a family with 2 children. Since it's a 2-part task, we can do a table, a product table. You can do a tree diagram if you want to, but a product table is fine. We have boy, girl as for the first child, that's the options we have. And then for the second child, we have boy, girl again. And then I'm going to fill out this product table. I've got boy, then boy, girl, then boy, boy, then girl, girl, then girl. So that's my sample space. Boy, boy, girl, boy, boy, girl, girl, girl. Okay, and now we're going to find the probability that both children are girls, given that at least one is a girl. So this part right here, given that at least one is a girl, that's going to shrink down our possibilities that we're choosing from. Given that one is a girl, those are these options, 3 options. Then both, we're finding the probability from those options that both are girls. That is a 1/3 chance. That's both girls over at least one. And then in part B, it says both children are girls, given that the older child is a girl. So now my sample space is going to change a little bit. I'm going to rewrite this. Given that, that's going to be my new denominator. The older child is a girl. This one, this one. That girl, the G written first means that that's the older child. So now my denominator is 2. I only have two options to choose from. And I'm finding the probability that both are girls. Only one of those options represents both girls. And that's it. That's all you do for that one. 2 events are independent if the probability of one event does not affect the probability of another event. So we are going to run through the formula of this to kind of determine mathematically if 2 events are independent or not, but I want to talk about this logically a little bit before we get into that. So if we're talking about independent means one does not affect the other. So if we're saying we have a deck of cards and we're going to draw 2 cards, then if I draw a card and I keep it out, I keep it in my hand, then now for my second draw, I have 1 less card in my standard deck. So my second card depends on what I drew in the first card, in the first draw, whatever card I got in the first draw. Now it's different if I draw a card, put it back, and then draw again. Then those 2 events are independent because one does not affect the other. I still have the entire deck of cards to choose from. Or dice. If I roll die, whatever I roll the first time is not going to affect what I roll the second time because all of the sides are still options. So rolling dice several times are independent events because it's not going to change the probability in the second round. In this one, we have a single card. So this should already tip you off. A single card is to be drawn. It's just one event. So we don't even really need to, anyway, it's a single card is drawn from a standard deck of cards. Find each of the following, given that, okay, A is the card is a face card. That's Jack, Queen, King. And then the card is black. There's 26 cards. This would be 12 cards. We want to find the probability of B. The card is black. That's 26 out of 52, or 1/2. Change that. And then the probability of B given A using the formula. So if I do the intersection over the second letter, the intersection of black cards and face cards. So if we just look at the face cards, how many of the face cards are also black? 6 of them. There's 12 total. 6 of them, half of them are black. So 6 out of 52. And then the probability of just a face card is 12 out of 52. Whoops. Because there's 12 face cards. And then we're going to simplify that. We get 6 over 12, which is 1/2. So what do you notice about parts A and B? They are equal. And when two events are independent, then the probability of B given A is going to be equal to the probability of B, the first letter. And then vice versa, we can switch those letters. We're going to see a little bit more of a few more examples of independent events in the next lesson, but that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help. See you in the next one.